All right. Here we go. So it says use a calculator. Before we even graph it, what should we do? There's one thing we should draw in. The asymptote. What's the asymptote? 3. So the number on the end is what kind of asymptote? Horizontal. So the horizontal asymptote is, but we don't just write 3. Y equals 3. Okay. All right. They want us to identify what the rate of change is. What's another word for rate of change? Not slope. Not in this case. Starts with a B. Base. What's another word for it? Starts with a G. A GR. Growth rate. Those are all different words for the same thing in this case. So what's the base for this problem? 5. So the number that gets the exponent, that's the base. Okay, so if we're ignoring the 5, then what are the other transformations that we've got going on here? Vertical stretch of 2. And we have up 3 and right 4. Okay, so I'm going to go ahead and graph this now. Got my y equals, I've got 2 times 5. If you want, you can put parentheses around the 5. It doesn't matter. So 2 times 5 to the x minus 4. And then we've got a plus 3. Henry, you have an older calculator, right? So when when you do your x minus 4, it needs to be in parentheses. So you do your up arrow, x minus 4, and then your plus 3. Okay. All right, we got it plugged in? Yes, yes, everybody should be plugging it in. Everybody? All right. I'm going to go ahead and just make sure my window's normal. I changed mine a lot. And then I'll hit graph. And do you guys remember in the video where I said you should look on your table to make sure you can graph all the points? Not the base. Has to do with the exponent. Yeah, so this says minus 4, so I'm going to look for positive 4. That's where like the easy points to graph are going to be. So I'm going to hit second graph. I'm going to look for positive 4, so I can graph the point 4, 5. 5, 13 is kind of hard to graph, but it's a little bit easier, I guess, than 3, 3.4. Oh, you could do either. So we've got over 4, up 5, and then over 3, up 3.4. That's not too bad. And then how do we know how to connect the points and draw the graph? What did the video say? Yeah. Yeah, it should make sense. It should follow the horizontal asymptote. So should I be like this? Yeah, that does not make sense. So whenever we have an asymptote, the graph needs to follow it. That's how asymptotes work. So this one, it makes more sense if you connect these and follow it this way than if you follow it on the right side. And then we're going to go ahead and just make it go up. So that's what the graph would look like. Okay, let's go ahead and flip to the next page and do one of those. So they're still asking us to graph, but they're going to ask for some more information. So first, can you guys tell what the horizontal asymptote is? Because we're always going to find that before we start graphing. 0, yeah, there's nothing on the end. This would be like a plus 0 on the end. And so that means that the horizontal asymptote is 0. So HA, y equals 0. Okay, this one doesn't ask us to find any transformations, so we can go ahead and just start with graphing it. So we have -2. I'll go ahead and put my multiplication using parentheses this time because it doesn't really matter. So times 3 to the x minus 4. I'll hit graph. And then when I look at my table, what x value am I looking at again to make sure I can graph it pretty easily? 4. So I've got second graph. I'm looking at 4. And I have the point 4, -2, and 5, -6. So 4, -2, 5, -6. And then what do I do with those points? Yeah.
Why did you put 5, -6?
Yeah, I did these 2 points because they're easy. This one's hard to graph. 18 is off the graph. So I always graph 2 points. I just pick the 2 easiest ones to graph. And if I look at the opposite sign of the number and the exponent, that will direct me exactly on the table to where the easiest ones are. So you don't have to look at that point. You could scroll around the table and try to find them, but that's going to save you a little bit of time because you know exactly where to look. Okay, so we've got those 2. What do we do with those 2 points? How do we know to graph it? Charlie? Hey, I'm up here.
Hi.
Hi. All right. So what do? Anybody?
Flow with it.
I want it to flow, and I want it to follow the asymptote, right? So should I draw it like this? No.
To the left.
To the left. It should go to the left. So I'm going to connect the points, draw the asymptote. I went really close to my asymptote there. Go real close. Maybe not as close as I did. And then I drew right on top of it. And then it should grow really fast the opposite direction. There we go. Okay. And then this one wants you to find the domain, the range, the increasing, the decreasing, all the stuff. So what's the domain? How far left does it go? How far right does it go? -infinity to the left, positive infinity to the right. So we got arrows. We got nothing stopping it. It's just going. What's the range?
-infinity to 0.
So it goes down forever, but when it goes up, you can see it doesn't go past my dotted line. It stops. So we're going to say -infinity at the bottom, 0 at the top. Okay. So increasing, decreasing. I'm going to go ahead. Say it again. There's no increasing. I've got my stick figure. What's he doing? He's definitely going down. Wouldn't that be a great slide? Look how steep that is. That would be like terrifying and also kind of wonderful. So yeah, let's think about it. So we're using x values, right? So what is the x value of a left arrow? -infinity. So the y value there is 0, but the x value is -infinity, and we're using the x. Over here we have a right arrow. What's the x value of a right arrow? Positive infinity. Okay. So for decreasing, we're going to say -infinity to positive infinity. What do we say for increase? None. It just doesn't. All right. In fact, these graphs are always going to do one or the other. They're not going to do both. They're just going to do one or the other. Okay. All right. How do we feel about that so far? We know what information to look for when we graph it. I always expect you to graph the horizontal asymptote. If you don't graph the horizontal asymptote, you don't have the whole picture. Okay? We always graph the horizontal asymptote. It should be graphed as a dotted line because in math, that's how we show that something is not really there. It's like imaginary, but it's important. Okay? We don't graph it as a solid line. Make sense? Okay. Go ahead and get started on that packet. If we run into issues later on in the packet, I can do some problems with you guys. Like the last page, we might need to do some of those together. That would be fine.